Sorry for this short delay. There were some technical issues on our end, but I hope that you hear us well, you see us well at the moment. Welcome everyone to our Alert and Icinga webinar. We really appreciate that you're joining us today. I'm Daria, Partner Marketing Manager at Alert, and our speakers today are Birol Yildiz, Co-founder and CEO at Alert, and Blerim Shekhar, COO at Icinga. Before we start, I will launch a poll in a few seconds so that you can answer your question, how you manage incidents in your organization. And while we are waiting for others to join, I'll address the first questions to our speakers. So Blerim, can you please share what do you think is the critical component of success of management of incidents nowadays?
Thanks for welcoming me. First of all, Daria, I'm happy to be here with you. So through the last over a decade now, we've seen many different scenarios where organizations struggle with alert fatigue, and I think that it's an organizational problem. Most companies suffer of. It can be solved by tooling a little bit. But the major thing from my perspective is assigning responsibilities to the things that are being monitored. Having clear responsibilities for each and every part of the infrastructure is, in my opinion, key to having a successful notification and alerting chain and escalation rules.
Thank you, Blerim, for your answer. And Birol, what is your take? Sorry, Birol, I think you're muted.
I guess now it's better.
Mm-hmm.
Yeah. So many meetings and so many webinars, but still struggling with technical issues. Yeah, thanks for having me, Blerim. It's a pleasure to do this webinar with you. I'm really excited about it. Regarding your question, Dasha, I think I would 100% second what Blerim said. Alert fatigue is like one key factor, and I agree. Alert fatigue to some extent can be solved with tooling, reducing alert noise. There are also like organizational things that can be addressed to solve alert fatigue. But I think at the core, alert fatigue can be also addressed by like really spending some time before you set up an alert and answering basic questions like, is this alert actionable? Is it really, is it something, is it just something that can wait for tomorrow? Like, am I alerting, for example, on like a host reaching 80% CPU or 90% CPU? Does that mean we've done something right? Like we have a right capacity, or is it really worthy of like getting woken up and getting up? If it can be automated, like don't set the alert at all. I think spending some time, spending some thoughts into carefully deciding what to alert on, that's one of the success factors for alert fatigue. And I think the broader question, and that's one thing we're also like very excited about, is like how can you even further reduce MTTR, right? Like we've been in the last 10 years, we've heavily like invested in tooling for like alerting and getting and solving the problem of MTTA, like really getting human attention if there are things that need immediate human attention. But then now the next phase is affecting the entire incident resolution process. And one part of that incident resolution is the root cause analysis, right? And that is a part that for the last decade has been done manually. And that's the next thing we're now trying to automate. And that's one thing I would like to showcase in this demo as well, how you can automate root cause analysis and take it from maybe like at least an order of magnitude down, like maybe like if it takes you now 20 minutes, probably an AI can do a root cause analysis in a few minutes, right? Maybe in a minute. And that will even help you reduce MTTR, tackle incidents, and increase uptime, which is the ultimate metric for any IT ops SRE.
Thank you very much for your response, Birol. Today we'll talk about the powerful features of Icinga monitoring and agentic incident response of Ilert, and have live demos of both platforms. Let me briefly introduce you to two solutions, and we'll jump to the demos and the presentations. So Ilert is AI-first company offering end-to-end all-in-one incident management platform for alerting on call management and status pages to help companies increase their digital uptime. And our dearest partner today is Icinga. Icinga is a powerful and comprehensive open source monitoring solution that integrates easily into existing infrastructures. It provides flexibility in configuration, automation, and scaling, making it ideal for dynamic and complex IT landscapes. And I think it's worth mentioning that Ilert and Icinga have an integration, so it literally means it takes seconds to connect two solutions together. We have a Q&A section, so feel free to drop your questions there, and we will do our best to cover them all in the last section of our webinar. And I give the floor to our first speaker, Lirim, please.
Thank you very much. I just requested to share my screen. Thank you for allowing me to do this. So just give me maybe 1 second so I really pick the right screen here. All right. Can you give me a quick heads up if you are able to see my screen? So I will just move forward. Thank you very much for the introduction, Daria, which is really nice because now I don't have to do it actually. Still, I will introduce Icinga to you. I just scrolled through the attendee list and I already saw some familiar names from known Icinga users. So thank you for joining us today. Probably for those of you who already know Icinga and use it, my part is less interesting, but I promise Birol's part will be super nice for you. I assume that the other half does know Ilert, but does not know Icinga. And for those, I would like to give you an introduction about who we are, what we do, what makes Icinga so special and unique. I promise it's going to be just a few slides. The rest will be a live demo. First of all, who am I? My name is Blarim. I work at Icinga for many years now. I'm the COO and basically responsible for daily operations. So basically everything that anyone else doesn't want to do, maybe. Icinga is a open source monitoring solution, and we usually describe Icinga by using 6 core components or 6 feature landscapes. At the core, Icinga is a infrastructure monitoring tool, and this is a very wide term. It includes basically anything that is connected to a network somewhere. The majority of Icinga users use Icinga to monitor their on-premise data centers or their private clouds or their public clouds or a mix of those in a hybrid environment. Icinga comes with dedicated automation features where it's able to connect to your existing databases and leverage data that you already have, because most of the people already have some kind of inventory data somewhere. So Icinga can use this so you don't have to start from scratch, and you eliminate human errors at the same time. As mentioned by Daria, Icinga comes with plenty of integrations as well. Ilert is one of them. There are others as well in the notification area, but also in the metrics and logs area. Icinga can be connected to different time series databases, such as InfluxDB, Graphite, Elasticsearch, OpenCSDB. It can be integrated with logging solutions and also with dashboard solutions like Grafana. Icinga itself comes with a web interface which allows you to analyze problems very quickly. We're going to see it later. And as an organization at Icinga, we basically want to enable or empower organizations to have a complete visibility into their IT infrastructure, no matter how complex or distributed it is. And we do this by basically delivering a very flexible and very extensible monitoring solution. We think that monitoring in general should be open. It should be customizable and also accessible by everyone in the organization. And with that idea, we build and maintain Icinga. So Icinga helps businesses, whether they are large and dynamic or hybrid or small, whether they are on premises. Icinga helps them to get insights into their systems, into their applications, into their services, across data centers, across clouds, with containers and other technology. Icinga alerts, of course, users when certain conditions are met. And we believe it provides a pretty easy flow to dashboards as well. So why do users pick Icinga? So at least what we hear from them is Icinga is uniquely positioned at an intersection between open source flexibility, and at the same time, it comes with an enterprise-grade reliability. And Icinga users choose Icinga because it does not have a black box logic. Everything that you can see is configurable. Everything that you have is extensible. It comes with built-in scalability. You can start very small and extend Icinga to very large environments. And it's quickly to deploy, actually. So it consists of some components. It's separated from each other. But you can start very quickly to monitor your first couple of services or hosts and extend it to a few thousand objects. Who do we serve? So as mentioned before, organizations who manage hybrid and complex infrastructures, it's MSPs, it's insurance companies, it's automotive, it's research. So there's no single industry that uses Icinga. Rather, it's used by many different companies. Typically, they have large IT infrastructure somewhere, and typically all of them, what they have in common is they want to know what's going on, and they also want to get alerted very fast if problems occur, and that's where Icinga comes in. How does it look like? If you open Icinga, the first thing that you will see is a very clean dashboard. So this is kind of the default dashboard that you get. Don't get irritated by my demo data here. It's a demo setup. No real services are being monitored here. So what you see which hosts do have problems currently and which services do have problems currently. And in between, you also can see things that have, or services that have recently recovered from problems. So the idea behind Icinga is to make it easy for system administrators to see the relevant information at a glance. So we do not add any information in dashboards or overviews that could be too bloaty or distract the user from the really important parts. Of course, there is more information. You can have different overviews, for example, for the current problems here. If you open such a detailed view, you will get different information here. So what Icinga does in the background is it periodically executes plugins to monitor different aspects of the IT infrastructure. A plugin is typically dedicated to one thing to be monitored. That thing can be a disk, can be a service, its availability, the response time of a service, the logs of a service, and searching for patterns. It can be the connectivity of a network device. It can be basically anything. If it's there, Icinga can monitor it. There's a huge community out there who's building those plugins. So most of them, the majority of them actually is not coming from us. We built the framework, we built the tool, but the majority of the plugins is coming from the community, and they share it with each other on exchange.icinga.com. And yeah, those plugins are executed periodically. You basically decide how often. Do you want to monitor something every minute, every 10 seconds, once a day? It's up to you. You get the output of the plugin, which tells you what is going on here. So in this case, we have a simple ping check. It just checks for the connectivity of something. And here it's in an OK state. So Icinga works with these 3 to 4 different kind of states. Something can be OK, something can be in a warning state, which requires your attention, maybe should have some attention. And there's a critical state. So this is something where it definitely needs your attention. And this is also why it's super important to have assigned responsibilities to those things, because what we see at our customer base is that whenever they receive alerts for something and the monitoring team or the system administrator does not know who's responsible for that, because typically the administrator is not the owner of a service or of a part of an infrastructure. Typically, they are responsible for monitoring it. And when they don't know who is responsible for that, they don't have automated notifications. They are struggling to find the right people, and outages last longer than they should have. And with Icinga, that's pretty easy. So you can define contacts and contact groups. In the detail view, you will get the details about the service, why it's critical. You can have different actions. So for example, you can acknowledge a problem, which basically means someone is working on it. So it stops re-notifying people. You can have scheduled maintenance windows. Here we call it downtimes. If you have upgrades running, backups or whatever, and you already know that object is going to be in a critical state because I will do maintenance work, you can configure that up front so you don't receive alerts for something that is expected. You can set comments. You will see also if a host or a service is connected to a parent, which basically means that you can configure dependencies from different objects to each other. That helps a lot when finding root causes. So for example, here we can see that this virtual machine is running actually on hypervisor 1, and on hypervisor 1 there are also some other machines running. The same thing works for network components as well. So you can imagine switches, routers. If the router is down, you don't need to receive notifications for the switches which are connected to it. That is configurable with Icinga. You get details about when the check was executed the last time, when it will be executed the next time, which helps in understanding what is going on. And plenty of other things here. I'm not going through everything. Maybe one more thing worth mentioning is that Icinga, of course, collects the history as well. So you can determine if an object is running into problematic status every now and then, or if it's a one-time occurrence or whatever. And each host comes with different services. So in this example here, we have a virtual machine and we have 4 different checks on this virtual machine. Typically in a standard setup, you would see here 10 to 15 services, depending on the use case, depending on what's running on that machine. In my demo here, I only have 4 to demonstrate what is possible. Here we have the load, the disk, if the cron process is running, if it's connected, and so on. I mentioned before that Icinga is highly extensible, and one way of extending Icinga is by creating modules. Modules are created by the community, but we use also the same mechanism to extend Icinga by ourselves as well. So when bringing large new features to Icinga, we usually create a module out of this. For us, it's good because we have a separate project which we can maintain separately. For the user, it's good because they can actually decide the feature set they want to have in their monitoring setup. So let's go through some examples. There's a module where you can create business processes. It's not installed by default. Users can pick to install it, can choose to install it. Business processes basically are a logical combination of different objects. You can imagine if you have a website and that website requires at least 3 out of 5 web servers and at least 1 out of 2 databases. You could create that logic into a business process and get alerted only on the top level if the website is down. The system administrator on the other side would be interested in the smaller pieces. There is something which we call certificate monitoring that is able to crawl your network and figure out where you have certificates configured. Recently this year, we released another module called Icinga for Kubernetes, which can monitor Kubernetes clusters. And this way we extend Icinga with more and more functionality. Since it's open source, all the libraries that we create and the frameworks that we have are publicly available, and they are being used by Icinga users to create their own modules. Some of the customers have internal modules. Some of the users decide to open source their modules. You can find most of them on GitHub or on Exchange, icinga.com. And one of the most important modules for Icinga perhaps is the Icinga director. So you can imagine that the default way of configuring Icinga is through configuration files. So you have plain text configuration files, and you define what you want to monitor in those files. With the Icinga director, we have the same functionality, but in the web interface. Across our user landscape, we think that 50% of the users approximately are using flat text files, and the other 50% are using Icinga director. So basically, some of the users like the web interface to configure things, and other likes text files. And with the Icinga director, you can almost do anything what you can do in the config files as well. There are a few limitations, but typically the major parts work here in the same way. So what can you do? In a very basic way, you can add hosts and assign them an address, assign them a display name. You can have host groups and host templates and so on. You can add services. The nice thing about Icinga director is that each and every change that you make to your configuration is tracked by the system. So you can later exactly see which change has been made by whom to the configuration. You will get a nice diff, which you know from Git. So it's a similar approach here, where you can exactly see, okay, the user ABC made this change and they deployed it at a certain time, which is nice to see. Another thing what you can do is if someone deployed wrong configurations, you can deploy an older version of the configuration at any time. So this is a very fast way to restore a working state of the monitoring configuration. And it gives you transparency into what is going on in your Icinga setup, especially if you are working in a team. That's the first part of Icinga director. The other part of Icinga director is that it comes with automation mechanisms. So what you can do is you can connect Icinga to your existing database. Most of the users already have those databases, like a CMDB or like a private cloud where you can get the information from the API. We've even seen users using Excel lists, but those are rare. How does it work? You have those import sources, and by default, you have different kinds of source types. In my example here, I'm using just plain SQL. So I'm connecting to a MySQL server here, and I'm just selecting a few information from that table. So what will happen if I execute this? I will have the information from my MySQL database available in Icinga. And I can do this periodically. So if the database changes, I will get the changes in Icinga as well. Next up, I can use this information and map it to Icinga configuration. For example, I could say that the object name equals the column host name, and the address equals the address column. Out of the location column from the table, I will create a custom variable called location and insert the value here. And this is very important. No matter if you are using an automation process or if you are doing it manually, one important part about Icinga and its flexibility and dynamic configuration is that it allows you to create these custom variables. Those custom variables enable you to you can imagine it like you describe your IT infrastructure and use this information later to express what you want to monitor. So by describing, you could say that I have this host here and I have a few custom variables for different things, so they are freely configurable. I'm using some same defaults here. So for example, I can have a variable where I can set if ilert should be enabled for this object or not. I can have a custom variable where I define which operating system is running on that machine. Which operating system version? Is it a physical machine? Is it a switch? Is it a virtual machine? And this way I describe how my IT infrastructure looks like. Now, if you remember, if you have this information already available somewhere, you can use that already. You can connect Icinga to third-party databases. You don't have to do this manually. You can automate these things. By doing so, you can use this information later to tell Icinga what it should monitor and how it should behave in terms of notifications. So first things first, Icinga comes with a rule-based configuration language. What does it mean? In the first step, we described our IT landscape. In the second step, we express what do I want to monitor. So a very simple example would be, okay, I want to use the ping check for every host where the location is Sydney. Super easy. Whenever I add a new host and its location is Sydney, it will receive this ping check automatically. Now, this is very, very straightforward. You can have more complex rules as well. You can combine them. You could say where location is Sydney and let's use the environment is production or testing or whatever. And this way you basically describe your IT landscape and you automate it in a way where you create rules that define what should be monitored with which check. So there are plenty of more possibilities, but in a nutshell, this is how Icinga works. There are other features available as well. So you can create, for example, service sets where you bundle those services. For example, here I can create a bundle out of the load, the disk, and the process cron check, which will create a service set. And then again, I use this expression to say, to tell Icinga, okay, these common services, please apply them everywhere where the type is set to dummy host. And whenever I add a new host and the type is dummy host, it will receive automatically a common service set with including a bunch of services. This mechanism, so the very same mechanism, can be used for notifications as well. I talked earlier about responsibilities. So what you can do is you can use these custom variables to actually describe things in your IT infrastructure and use this information to route the notification to the responsible people out there by using this rule-based configuration. I will demonstrate it in a very basic way. Notifications are are executed in a very similar way how check plugins are executed. So whenever Icinga determines that something is in a problematic state, what it does in the background is it executes a notification command. Very simple. A notification command is some kind of executable on your Icinga server, typically written in Python or plain Bash or whatever. But it just executes this executable, maybe with a bunch of parameters to make it dynamic. And this is what we have with ilert as well. As most of you probably know, is ilert has a very good API out there, and the people of ilert were super nice by creating an integration for Icinga, which exists now for plenty of years. So it's very mature and it's working very well. There is a super nice documentation on the ilert website, so I'm not going through the documentation because it's super easy to follow. It comes with a very sane default config that you can use. Rather, today I choose to show you how you can do this in Icinga Director, because it allows me to introduce Icinga Director a little bit to you, but it also gives me the option to show something new to you, because going through the documentation is probably too boring for the attendees. So first things first, Icinga executes this executable when it thinks a notification should be sent. So what we do is we create a command template. I'm using here this webinar because the production one has my API key, but the rest is similar. So we have a command. First of all, we are creating a template here, a template that we can use later. This template has the basic set of configuration parameters. It has a command type, which is a notification plugin command, obviously. It has a name, freely choosable, and we kind of teach Icinga how this integration works here, because the ilert Icinga integration is a Python executable, which you download and you place it on your server, and Icinga is able to execute it. So we teach Icinga now, how does this command work? Which parameters does it have? Where is it on the file system? And so on. So first of all, we are telling Icinga, okay, for this notification command, please use this script here, ilert icinga.py. And the script has some optional and some required parameters. And we can define them in the arguments section here. So by teaching Icinga that this script has a parameter called -mode, and we're always going to use the Icinga mode. We are telling it that the endpoint for API is api.ilert.com, and we tell it that our API key, you receive this API key when creating an ilert account. I think it's the second or third step in the setup, super easy to get this. And we have some very basic configuration parameters here. So the notification type is what it's all about. So is it a problem? Is it a recovery of a problem? Or is it an acknowledgement? So these three types are supported by the integration. We have an author name. So who authored this notification? If it has a comment inside, and we have the date and time of the occurrence of this notification. Now we have the basics all set, and our next step would be to create the actual commands. With Icinga, we separate them. We have one command for host alerts, and we have one command for service alerts. Both of these commands use the template that we created before. So the only thing that we have to set here is the arguments dedicated to host. I will only show the host thing here. So the only thing that we have to create here is the arguments related to host problems. So the host address, the host name, the host alias, the host state output, and so on. Ordering is important here. Why is ordering important? Because it's just the way how the script works. The Icinga alerted.py expects those three, that's the first arguments, and the rest of those have to be after the initial parameters. But that's not a problem at all, because you can define the position of each argument in the configuration. So the host address is at position 11 and so on. So now I told Icinga how this integration works. This is something that I only have to do once and then never again. And the next and final step is super easy, because I only tell Icinga. Now we come back to the rule-based configuration. I create a rule, a notification rule, and tell Icinga, assign this rule everywhere where the host variable enable ilert is set to true. Super easy. So it's a host notification rule. It uses a certain command. And whenever there is a custom variable set to enable ilert set to true, it's going to use this integration. I prepared a sample host here just to show you that it actually works. I'm going to set check results. I'm going to process check results manually. Just let me open the alert dashboard. So it's empty right now. If something goes down, I am down. It's very quickly available in the alert interface as well. So we see here the same information that we have in Icinga as well. I personally like the timeline view here, because it shows you how the alert behaves in the future. Now let's say we have a problem here. Now I am working on a solution, and alert will recognize this as well. So we received it translates the acknowledgement to an accept event in alert. And the final step would be I solved it. I'm gonna just tell it it's up again. And alert will receive this information as well and create a resolve event out of it. So this way you can use Icinga to monitor your IT infrastructure and use alert for notification routing, and also plenty of other features which Bureau can demonstrate to us. Thank you very much.
Thank you very much, Blerium. It was very insightful. Just a reminder that we have a Q&A section in this webinar, so please drop your questions there. I also see that there are some questions in the chat. We will read them and try to answer all of them at the end of the webinar. And also please answer the questions in the poll. I think something around 35 people already shared their experience, so your experience is also very valuable. Please share your responses in the poll. And I'm passing the mic to Biral, please.
Thank you, Dasha. I assume you can see my screen and hear me well. Yes, so this seems to be working. Thanks again, Blerium, for this demo of Icinga, and also how the integration ecosystem works and how ilert is integrated with Icinga. I actually wasn't aware. I knew that there is like Icinga director, but I wasn't aware of the flexibility that you just showcased. So thanks for that. That's very insightful. Now imagine the same alert that Blerium just triggered. It does more than alerting you. It does, like, by the time, imagine it's 3 a.m. in the morning, and like you get a phone call from ilert. That's what we do after all. We do on-call management. We do alerting. Our primary, like how we started is, we started as an incident response management solution, and the primary goal was always to like bring human attention immediately to things that require immediate attention, right? And usually those events come from monitoring tools, observability tools, sometimes also ticketing tools like Icinga. And now imagine that you get an alert, it's 3 a.m. in the morning, and you acknowledge it. You can, by the way, also acknowledge it from within ilert, because if it's 3 a.m. in the morning, you get a phone call, you just press a button and then the alert is acknowledged, which means you're taking responsibility, which means you won't get another phone call or you won't be messaged on other channels, which also means that the alert will not be escalated to your backup. You might have a colleague that will also get alerted if you don't respond within a few minutes, right? So you acknowledge the alert, and by the time you open up ilert, you don't see just a raw alert from Icinga, you see a complete root cause analysis. And let me explain to you how we're doing root cause analysis, or how we're helping you with root cause analysis. We clearly believe with like the recent advancements in AI, we're heading to a world where you will actually only be paged for an incident if your AI teammate is not able to resolve the incident on its own. For now, we're starting with root cause analysis, and that's the part that takes like significant portion of the entire incident response lifecycle, like apart from routing, getting human attention. The second part of the incident lifecycle is like root cause analysis. And before I jump into the live demo, just let me show you a brief overview what we're doing to do root cause analysis. In fact, we have implemented agents, or you can configure agents and give those agents access to the systems that you are using to do root cause analysis. Usually it's like the first thing you do is, of course, when you get an alert from Icinga, you check Icinga, right? But then maybe you have a logging system where the actual application, like you'll receive a service alert from Icinga, and then that service running on a host hopefully like sends out some logs to your elk stack, for example. And then you have metrics, which Icinga again pushes into Influx. So these are all the systems that you can provide the agent access with. And by the way, the access can be read-only. So just to reduce the risk and increase the like your confidence into like using a responder agent. And by the time you open up your laptop, you, instead of presenting a raw alert, you are presented with like key findings, with recommended actions, and also like related data that support the key findings, the root cause analysis that your agent came up with. So now let me head back to ilert and just show you a very basic configuration of an agent. Let's go to agents. And I have pre-configured an agent specifically for this webinar. And this agent is equipped with access to a few GitHub repositories. So it's able to see whether there were any deployments, code changes. This agent is also connected to Elastic, where it can fetch logs for any alerts that we receive from ilert or from Icinga. And it's also connected to Grafana and Influx, where Grafana we're using for to visualize the metrics that we have in Influx. And our Influx database or Icinga, the Icinga instance that I'm about to show you is configured to write its metrics into Influx, and we have configured a dashboard on top of our Influx DB. What I'm about to show you is a sample application that is being monitored by Icinga, and we're going to like simulate an incident. And this sample application is a like very simple to-do app. So I can have to-dos, attend the webinar, answer questions. And again, this app is monitored by Icinga, and the right now, so everything is looking good. When we go to the Icinga dashboard, we have no service problems, no host problems, luckily. And we're using a basic HTTP check plugin, which measures the latency of the response time and pushes that data to its connected InfluxDB. And here we can also see the graph in Grafana. So right now, everything is looking good. For the last 30 minutes, let me refresh this. For the last 30 minutes, response time has been like below 15 milliseconds, which is like pretty decent. And I also happen to have a status page, which is again hosted by ilert. It's part of the product. We are a complete incident response platform. We not only cover alerting, we cover alerting on call management, status pages to help you communicate incidents effectively. So everything that you usually do as part of the incident response lifecycle, that's an area where we help you with one way or the other. And this is the simple status page that I've configured. It contains the application itself and also a few services that is part of the application. So this application is wired in a way that it's going to now simulate increasing response times the more requests it's getting. So of course, it's very popular. So I'm going to do a few refreshes. And as you can see, the response time is now increasing. So, and I'm going to do another call of this application, and it really takes long. So what's happening here? Maybe Icinga has already discovered that the response time is behaving not how it should behave. Let's try this again. Now we can see like clearly something is wrong because it's taking too long for the application to refresh. And I'm expecting that, how can I get rid of this? There's a toolbar from Zoom, which you probably don't see. So by now, Icinga has detected that there is a service problem because the latency is going up on our simple to-do service. And if we go to ilert, we can see that an alert has been created. And I'm not going through the details of I get a phone call and I need to acknowledge and so on and so forth, because like that's, I assume I also saw the list, like most of you are probably familiar with how alerting works, how alert acknowledgement works, and what escalations are. And in a nutshell, we cover probably like we solve every alerting problem that you can imagine. If not, please shoot me an email and I'm happy to go over it. And I'm also now like getting alerts. Let me quickly acknowledge this so I'm not alerted further. Refresh this real quick. And like one difference here is that we are there is an agent that has like kicked in and is doing already a root cause analysis, right? So let's have a look at it. So right now we see the alerts, the information provided by Icinga. Let me get rid of this status bar. The information provided by Icinga, the alert details, and let's see what the agent is doing to understand the root cause of the analysis. So it says the investigation has started. It starts with looking at deployment data. And I think that's like very smart because usually when things break, the first question you ask is like, what has changed, right? So it's change that caused incidents, change in software, change in configurations, change in the infrastructure, right? That's the number one reason. And there is no instruction for the agent. That's where we tell it like, go and look at deployments, right? That this is something that the agent, it decides its own trajectory. It has to solve the specific problem, find the root cause for a very specific alert. And it now runs in a reasoning loop until it reaches that goal. And now the second step is it has checked the logs. That's what I do usually too. Like whenever there is an alert, I check the logs, right? And it says, okay, completed the expert-assisted analysis of the logs, performed thorough specialized tool, and retrieved the relevant information. Like it's a little bit verbose, while noting that the operation finished successfully. So this looks good. And it also looked at metrics and checked the Grafana dashboards. So it has like executed a bunch of steps within a few minutes, right? I think it was less than 2 minutes. And let's see what the key findings are. So it says the HTTP response latency spike to up to 8 seconds matches also what the alert says. So this is what the alert says, 8 seconds. This is what we received from Icinga. And the agent was able to confirm this by looking at the response metric in InfluxDB. This spike directly correlates with slow access logs and the alert summary. And now this is probably the actual root cause of the problem. So repeated MySQL connection pool timeout warning observed across the same window. So it's getting this information from Elastic. And it says these occur immediately before and during the HTTP latency spike, indicating DB connection exhaustion or connectivity issue. And it's also notices that there were no related deployments that could be related to this alert, which is true. And there are also a few actions that the agent recommends. Like first and foremost, this is a hugely popular to-do app, so I should probably update my status page so my users are aware that there is an ongoing incident. And it in fact creates a to-do for this, to update our status page to create an incident. So let's go ahead and do this. And like based on its root cause analysis, it now creates an incident to update our users. And this update, this incident will be then reflected on all status page that includes the simple to-do service. So let's create this incident and mark this as done. And then there are a few recommendations on how to actually fix this. Run the DB deconnect pool remediation playbook on the service. We actually have prepared such a playbook, so which is this alert action. So let's run this alert action, and I expect that Icinga in a few minutes or in a few seconds detects that the simple to-do app is responding normally again, and it will resolve this alert. But let's have a look at the other recommended actions. So we just did that too. Open logs for Snappy to do. Okay, I think there is no need to check the logs again because that's what the agent did for us. And if you have noticed, the alert is now resolved again because we executed this playbook that like restarted the connection pool, and now the app is behaving as expected again. Like in this case, it wasn't even necessary to ask any follow-up questions. So like, let's say sometimes the investigation is maybe it's not complete, and you could even interact with your agent and say, what was the historical latency in the last 3 hours? So just let me try this. And again, the agent uses its capabilities to provide an answer to my question. So it will now decide, okay, I'm interested in like historical latency in the last 3 hours. And probably it will come to the conclusion that for that, I can find the answer in the metrics, and it knows like which bucket to look at based on the context it was provided. Okay, the latency is again behaving not regular, but let's see if it's able to come up with an answer regarding our question. And by the way, like I know like there are many customers in this webinar, and like one question you might have is, I don't have this agents tab, right? And you also didn't see this if you paid attention in Blairham's demo. That's something where like it's very early. We've been working on this for like quite some time now, and we have an early access program with a select customers where we are further like developing this capability. So if you, it's very likely that you don't have access, but if you're interested in participating in our early access program, feel free to reach out to me, to reach out to our support, and then we will have a brief conversation with you and potentially onboard you to our early access program for this agent. So it was able to answer my question: historical latency for Snappy to-do sketch over the last 3 hours. Baseline remained low. Yes, I think that's what we saw too. But there were repeated significant spikes above 5 to 8 seconds at multiple times, and here it lists the time. So I think probably the same things that like an IT ops guy or an SRE would do: check logs, check metrics. And this is, in a nutshell, how the agent works. And you can have multiple agents, right? So it doesn't have to be this one agent that has access to everything. You can have an agent for each team and just treat it like a new joiner in your team, where, okay, you are part of my team, and then you get access, first of all, like read-only access to these and these tools. And this is how we design and develop our agents. Internally, it uses the MCP protocol, and it's able to connect to your systems without you having to make any change to your Elastic, to your Graylog, to all the systems that we support. This is a list that we've developed in the last like 2 to 3 months, and we're continuously adding new capabilities, new tools, based on customer demand and customer feedback. I think this concludes my demo. What I didn't show you is probably the status page, right? This is the status page where an incident was created from the alert itself. Again, ilert is an all-in-one platform for incident response. We cover alerting, on-call management, have an AI responder, and also incident communication via status pages. Thank you. I think I'll hand it over to Dasha
Thank
for
you
next
very
steps,
much.
and also to cover questions.
Yes, thank you very much, Birol. We do have a few questions, so let me go one by one, and that's the final reminder to share your answers in the poll. So the first question will go to Blerim. So the question was, what is the easiest way to consume SNMP trap? So I guess that's Simple Network Management Protocol from equipment.
So out of the box, I can think of 2 ways. So one is using SNMP-TT, which is a well-known tool to receive SNMP traps. It has an official integration with Icinga. It basically sends the traps that it receives to Icinga as a passive check result. A passive check result is so what we saw in the demo were active checks. So Icinga is doing actively something. It also works the other way around. You can send data to Icinga as well. This is a passive check result. And SNMP-TT does exactly that. It has a native Icinga integration. The other way would be, for example, by using Logstash. If you are familiar with that, it comes from Elastic. Logstash has different inputs, it had different filters, and it has different outputs. Logstash, there is a SNMP trap input for Logstash available, and there is a official Icinga output available. The Icinga output is written by us. The SNMP trap input is written by someone else, but you can combine those and receive the traps with the input. You can filter them and enhance them, enrich them with additional information, and use our Icinga output, which uses the Icinga API to create those services and hosts them dynamically based on the traps.
Thanks a lot, Blerim, for your response. Birol, I think the next question is to you. Did you train the LLM yourself, or is this a public paid pre-trained one?
No, we didn't train any like foundational model. We're using large language models provided by OpenAI, provided by Anthropic, and the hosting is dependent on our customer location. So for European customers, we're using OpenAI models hosted by Microsoft in Germany. For cloud models, we're using AWS Bedrock, hosted in Frankfurt here too. So to answer the question, no, the model, we haven't trained the model. We're using sophisticated reasoning models pre-trained by large language model providers.
Thank you. And one more question related to Ilert. I see that Ilert supports an outbound integration with Jira, which only seems to cover Jira software, not Jira service management. Do I understand this correctly? Any plans on including GSM as an outbound integration?
Yes, we do support Jira, both Jira software and Jira service management. So both integration should work, and we have customers like using Jira service management too. If you happen to have any problems, please like reach out to support@ilert.com. But yes, we do definitely support Jira service management too.
And
For
one more question related to Alert. Can voice phone calls or emails be interpreted into incidents and converted to alerts?
Yes. Maybe I'll show you this overview here. So we position ourselves as the central dispatcher for any kind of critical event. So any event that needs immediate human attention, we have an integration for that. So these are not only solutions like Icinga in the monitoring space, in the observability space, solutions like Jira, ServiceNow for tickets, both inbound and outbound, but also things like you have an email inbox, you have a device that's capable of sending email. You can create an email alert source in Ilert, or you want to provide a way to report incidents via a phone number. So you provide your customers, or you have an internal emergency hotline, and people can call that hotline and either be connected to the on-call responder, or have them leave a voicemail, or even have them talk to an agent. We also have a voice agent that's capable of doing a few things for taking incident calls. So yes, the answer is yes. We provide support both emails and phone calls, and you can turn those into like incidents and get notified and apply your usual incident response procedure.
And we have one more question from Glenn. Would Alert be able to differentiate between an isolated real alert and the flood of alerts caused by a major outage, and therefore avoid creating potentially thousands of individual tickets for the individual alerts?
I think, like, first and foremost, I would like highly recommend, and I think Blurrim showed a few like capabilities in that regard, to model any dependencies in the monitoring tool itself, because that's where the knowledge is, and Icinga is very flexible in that regard, where it lets you say, okay, this host is dependent on this switch, and I know if this switch is down, it probably affects all these other hosts too. So, and of course, we are aware that like in practice, it's like it is a challenge, but try to do your homework first and foremost on the source side, so you're not flooded for many alerts because of like obvious dependencies that weren't modeled. But yes, Ilert helps you with like we have many features to help you. First of all, you cannot be flooded with phone calls with Ilert. We have many features where we prevent, where we apply intelligent grouping, for example, where we don't give you multiple calls regarding the same alert, where we don't create alerts in the first place because you have configured something like semantic grouping. We also have an AI-based grouping where the AI is able to understand the semantic meaning of an alert. So even if it's completely different on a textual level, because one comes from Icinga and the other one comes from like another monitoring tool, it will still be able to correlate those and group those. And there are like very simple techniques like that you can apply, things like time-based grouping, right? Where you have a window of 5 minutes, and you aggregate, you only create at max one alert per 5 minutes, and every subsequent alerts is aggregated into the existing alert. So yes, we do provide a host of capabilities to reduce alert flooding and reduce alert noise. And I think that question is worthy of a dedicated webinar, where we start with Icinga and showing you how you can model dependencies between services and hosts, and then in Ilert, where we show you like the different levels of aggregation, grouping, correlation that you can apply, and there are many.
Thank you, Birol. And I think the last short question, and we'll have to switch to the results of the poll, is ilert open source product? And also like expanding this question, when these capabilities, especially with the MCP server for Icinga, will be available for a wider audience?
No, ilert is a commercial product. It's a cloud-only product. And we think alerting and like the incident response has to be like decoupled from your operational infrastructure. And we've built ilert in a way that's like highly available, spread across multiple geographies. We're hosted not only in Germany, we were in Stockholm, we're in Dublin. So it's an HR, it's an HA, it's a highly available architecture that we're using, and it's highly distributed. And we think that it's a product that should be used in the cloud, and it's decoupled. That's why we don't provide a hosted version, and it's also not open source.
Thank you very much, Birol. Unfortunately, we are running out of time. There are still some questions dropped in the chat. So please, if you have more questions, reach out to our support team or to Icinga support team. We're open to help you. And I finished the poll. I think the answers are really interesting. So question number 1, what is the biggest challenging in managing incidents? And this is more or less obvious, alert overload. And I think we had many questions today in the chat related to noise canceling, alert correlation, grouping and stuff. The next question was, which incident metric is the primary within your team? And the answer was, we haven't started tracking incident metrics yet. I think that's really interesting. And the third question was, have you already integrated AI into your operations? And we have 45% and 45% saying both no. And one group is saying no, but we plan to. Another one, no, and we have no plans to. I think that's amazingly described the industry situation at the moment. Thank you everyone for joining today. It was really pleasure having this webinar and these insightful talks, and we'll send the recording probably tomorrow morning as soon as it's ready. Thanks a lot everyone for joining. Birol, Plirim, it was a pleasure. Thanks a lot and see you. Bye.
Thank you.
Thank you very much, everyone. Bye-bye.
Bye-bye.